Hi, welcome to the chapter 2 of the data analysis course.
I am your instructor. My name is Bhavishya Pandit, and today in this chapter we will be focusing on
The objective of this chapter is to cover the following things. We'll be taking a revision of the previous concepts learned, a few of the previous concepts learned. The second thing that we would do is we would understand and learn what data preprocessing is. In data preprocessing, we would understand how to handle missing values and how to encode categorical data. In the second part of this video, we would understand how to filter the data. Now, uh, let's clear all the inputs so that we'll be able to see how things work. So for that, we'll just go to cell type, all inputs, and in that, clear. So all the outputs have been cleared about the of the code, right? So firstly, we would be importing the data. So to import the data, we have to write import pandas as PD, import numpy as np. So both np and pd are alias as we have learned in the previous chapter as well. So about this data set is about life expectancy of different countries from a given range of years. There are a few other features that are also mentioned. So and you can get this data from this link here, and so this is exactly how the data looks like. So from this link you'll be able to access that, and also from this you'll be able to you'll be able to see all the notebooks and the chapters along with the data that I had mentioned in the course as well. So let's get started. Let's read the data first. So to read the data, we have to write pd.read_csv and then the name of the file where it is located, right? And then the head function would show us the top 5 rows by default, right? So that is exactly how the data looks like. There are 22 columns. So let's see how many rows we have. So when we run it, when we do data.shape, it gives us the total number of rows that we have. So it shows us that there are 2938 rows. Okay. So let's get started with the missing values and the data imputation part first. Before that, let's see what are the different data types of what are the different values. Let's explore a bit. So I want to know how many unique countries are there in this data. As of now, I'm just able to see Afghanistan. Is it all Afghanistan, or there are some 5-10 countries, or there are 100 countries? I'm not sure of it. Here I see only like some 2011 to 2015, and also this data is not in order. So I want to know how many unique number of years are there. So let's see from this code. So it shows that unique countries are 193 and unique number of years is 16 across different years, across different countries. So to find that, what we had done was we wrote the name of the data frame for what column we want to find, and n unique stands for number of unique values it gives. Had it been unique, only unique, instead of n unique, it would have given us all the unique values, right? Here we see all the different unique values of the countries that are out there, right? And if we write n unique here, it would give us the count of it. So, and now I want to see what is the maximum and the minimum year that we have. So here we have, it shows us that okay, there are 16 years, but what is the maximum and minimum, right? We want to see it. So it shows that the minimum is 2000, maximum is to 2015. So the data is from 2000 to 2015, 16 years in total. So here if we do the math, it shows us that it would be 3088, right? And here it shows that the number of data that we have is 2938. So that means that not all the countries have the data for 16 years. That is what it shows, right? So there are a few countries who have data starting from, let's say, 2008 or 2006. That means they do not have the data. Not all the countries necessarily have data starting from 2000 to 2015. There would be slight of missing values in that case. So yep. So let's see what are the different object categories that we had got, right? So what exactly do I mean by that? So here you'd be encoding, right? So encoding basically is that you more or less want to focus on only those variables which are not numeric, right? So machine only understands in the form of numbers and not in the form of strings and all of that. Language, English, Hindi, all of this is unknown to machines, right? They only understand numbers, right? So right now, if I'm communicating with you, you're able to understand whatever I'm trying to say because I'm interacting in a language which we both understand. Similarly, if I want to interact with machine, I'll have to communicate in a way where the machine would be able to understand, right? And that is exactly why we go for numbers, numeric form and all of that. So this basically gives us those data frame, those columns which have object data, object type or category type, right? So here, if I go ahead with it, it would show us that only two columns have the object type, right? So the object basically is that string. Had it been integer, int, probably it would have been something else. See, we did not get anything, right? So for object, we'll go for it. Now see, since you see that's the case here, probably we might want to give it a try for float. Let's see if float works here. So yeah, float works here. So from float we are able to get so many values, right? So if we just remove category here, right, and if we write, let's say, object again, right, it would give us all the values, all the columns which have non-integral, non-numeric values in the columns, right? So yeah, so for status, for country, I know that okay, there are some 12 sorry, 16 unique countries that I have, but I'm not sure of developing, which is in the status, right? What are the different values of status? So let's say we'll go ahead with this value counts, right? So it shows that there are two categories in status. It shows that developed countries or developing countries, right? So for developed, there are 512 entries. For developing, there are 2426 values, right? Not these are not countries basically, but right, there are the rows, right? If you would have gone for like in unique, it would have been only two, right? Because it would have shown that of all the values that it has, only there are two values which are developing and developed. So 2426 and 512 only shows the occurrence over here. That means that Afghanistan developing 2, 3, 4, 5. This is developing only, but the occurrence of developing in the first 5 rows is 5, and that is exactly how developing is calculated across the values in this data set. Alright. So now let's get started with the missing values and imputation. So basically, from the last chapter, you have understood what missing values is. So missing values is like when the data is not present. Right, missing values is not zero value. It is when the data is not present. So missing value usually is denoted by NaN, which stands for not a number, right? And it needs to be treated because if it is bypassed like that without being treated, it might actually cause us issues and biases, right? It might not give us the accurate results. And so as to make sure that we don't go through that, we impute the missing values. We handle missing values. What are the basic three ways of imputing missing values? So basically, imputing means replacing. So if there is a missing value, if there is no value, how do we treat it? So that is what imputation is. So of all the methods that are out there, three are the basic ones, right, that you can use. Mean imputation. So what do we mean by mean imputation is we replace the missing values with the mean of the column, right? What is the median imputation? We replace the missing value with the median of the column, right? Column means like if this is it, right? So in ethnicity, I'd be taking a median of all these values, right? And then when the median that I get, I'd be replacing it over here in this section that you can see from the cursor, right? So that is what median is, and hence similarly for the mode, right? In the previous chapter, what we had done was we had dropped the NaN values, right? So, but here we will be treating them, right? So you can either drop the NaN values, you can either impute them. It totally is very subjective and depends from the use case to use case. Depends on the use case and what is the number of missing values if you're having. If the majority of the values that you are having in a column are missing, then it is better to drop it off rather than imputing it, right? So I would want to see how many missing values are here, right? So this function helps you give us the sum of all the missing values in the respective columns. So if I run it, it shows me that life expectancy has 10 missing values. Infant has 0. Adult mortality has 10. This GDP has 448, and all of these things, right? So now I want to see how would I be able to fill the missing values, right? So one way of filling the missing values is by using let's say we are filling the missing values using fill_na function, right? So you can impute values by fill_na. So what would actually happen is it would impute all the values by taking the mean of them, right? Since these values that are categorical, or I would say not numeric, right, are not having any missing values, we would be able to use this function. Had it been like that, we first would have had to encode them, then we would have had gone to I would say filling the missing values. If let's say there would have been missing values in country and status, and if you would have had run this fill_na function, right, it would have had given us error because it does not understand string values. For it to fill, it has to be in numeric form only, right? So what we would do over here is we would fill it by this, and then we would do is sum.mn, is null.sum, and then we would see that whether there are any missing values or not. So it shows that now there are no missing values. That's good, right? So now this is one way of doing it, right? Here we have, here if I would run this thing again, it would still show because I have not replaced that cell yet, right? For me to replace it, I'll have to do it like data equals to data dot this, and then I'll have to remove this thing, and then if I run it, then it would show me. Now if I run this cell, it would show me again, right? Since I did not do it earlier, it still showed like that. So let's see if I want to impute only one specific column, right? So in that case, what I can do is, let's say I want to impute let's say we want to impute BMI. Okay, so BMI, I want to impute it by this mean of BMI, right? So right now it is showing that there are 34 missing values in BMI. So if I'll just do is null.sum on this, right? So now here it is showing that there are no missing values in BMI and everything, right? But when I'll change it, since now the expected output is it should come 0 over here, and all the other missing values will be would be intact, right? So let's see if it would work or not. So it says that there is no attribute with the name BMI. So that means that the name is different. There are spaces and all of that over here. So that is why it is taking like that. Let's try for polio, because I believe polio does not have such an issue. So let's try for polio. Okay, so it shows that there are no missing values in this thing, right? Because we have already filled it up. So if I go like this, data equals to, or data.polio, I'll have to do it like that only then now. So data equals to data.polio, and then I want to show it to you, and data.isnull.sum, right? If I show it now, it would show what it would show that polio has 0 missing values and all the other would have missing values, right? Let's see. So it shows that polio has 0 missing values now, right? But all of them have the missing values like the same only. But I want to fill all those missing values, right? So let's say I want to fill all of the other missing values by median, right? So you can simply write median here. If you want to impute by mode, write mode here. But let's say in this case I want to do it with mean, so I'll just keep it mean over here only, and then I'll simply run it. So now you see that I have all the missing values covered. All the missing values have been replaced by mean. So that's how you impute missing values. You do not have to impute with mean always. You just have to you'll have to understand what your data is like and how you'd be able to do that. So that's how you impute missing values. Now let's jump on to the encoding part. So in this part of the video, we'll just be covering the data preprocessing part, and that is handling missing values and encoding. In the second part, we'll be covering how to filter data and all of that, right? So in encoding, if you see very carefully, right, the categorical variable is the one that I've had told you earlier, right? This one, which has non-numeric values, right, string values. So basically, in categorical variables, there are usually two variables. It is bifurcated into two parts. The first part is nominal. The second part is ordinal. But what is nominal? Nominal has no specific order. It is just a bunch of categories like pen, pencil, eraser, or cow, dog, cat. Right? There is no specific order. right? There is no specific priority or precedence. But in ordinal, what happens is there is a set priority and a set order. So let's say where we see that excellent is has a higher priority than good, and good has higher priority than bad. Excellent has a higher priority than both good and bad, right? Similarly, fantastic has a higher priority than okay and don't like. Similarly, so that is what ordinal is, right? So in a few cases, we don't really care if there is an order or not. We just want to encode it. Like in the case of country, right? We don't care whether there is an order or not because there is no specific order. We just want to encode the country names, right? Because it would not understand it otherwise. But in the case of status, we want to encode it. We want to understand whether there is a specific order or not. Here, we would probably give developed countries a higher precedence than developing countries, or vice versa, and all of that, right? So that is why ordinal is important. So now, here are usually three types of encoding are used in the data pre-processing aspect, right? For starters, we go ahead with label encoding part, right? So label encoding basically is that you label the you just label the country names. So here we have Afghanistan and all of that above, right? So you'll just be encoding all of those values and they will be encoded in the alphabetical order, right? And so here in this, I have given an example of, let's say we have three countries, right? Australia, India, and UAE. So if they were to be encoded by the alphabetical order, Australia would be encoded as 0, India would be encoded as 1, and UAE would be encoded as 2. Here, this label encoder package can be found in sklearn preprocessing class, right? But one caveat that we have is it encodes only one column at a time. That is one aspect. And why is that? Because usually this label encoder is used for classification purposes or for those purposes where we want to in machine learning where we want to encode only the target variable, right? But here the case is different, right? So that is a different thing. So ordinal encoding we would come up to. Ordinal encoding is same as label encoding, but one thing that is good in ordinal encoding is it can encode more than one columns at the same time, right? It will encode more than one columns at the same time, and it also handles the priority, right? Like excellent, good, and all of that, right? That also it handles. So that is what ordinal encoding is. So now let us understand what one-hot encoding is. So one-hot encoding helps us get rid of the ordinal bias, right, created by the encoders. So here, if you would see that we have these values, right? Dog, cat, sheep, horse, lion. So when they would be encoded in the alphabetical order, if I would see, I would encode cat as 0, then probably dog as 1, then horse, then lion, then sheep, and all of that, right? But in that case, what actually happens is it would have been very, very difficult, right, to encode. And then let's say there are a lot of things that you would want to see, or let's say there are not a lot of columns. So in this case, what actually happens is one hot encoder, what it does is let's say we have how many categories are we having? 1, 2, 3, 4, 5 categories we have it. So what it would do is it would eliminate this column, and instead of this column, it will have a separate column for all the different categories we have. So rather than 2, we would have one column here and 5 more columns, that is 6. So 1, 2, 3, 4, 5, 6. We have 6 columns in all. And for every index, if a particular category is present, it would represent it by 1 and the rest as 0. So here, if you would see an index 0, dog is present. So it has marked dog as 1 and the rest as 0. Similarly, in the second one, cat is present. So 1 is for cat and all of them are 0. So if you would observe carefully, every row will have only one at a time, because there are, in this case and in most of the cases when you are using one-hot encoding, one row will have only one and the rest of them would be zeros, because there is only one category present at that specific time. And that is exactly how it works, right? let's see how it works in Python. How do you implement it in Python, right? So you can call these both the classes from sklearn's preprocessing aspect, right? And that the name is ordinal encoder and one-hot encoder. Let's run it, right? Let's make an object and then see how it works. So when we run it, what it actually is doing is it is instantiating, and it has made an object, and then we are fitting and transforming the data, right? And when we fit and transform the data, it has transformed the data into a data frame again. So if you remember earlier, our data looked something like this, right? These two columns were there. This was the data earlier, but now our data looks like this because we have encoded, right? We have encoded. Now, what we want to do is, I want to find the total number of, I want to one hot encode, right? Now, since I had told you earlier, what one hot encode does is, it would encode that specific column, and for all the different categories that it would have, it would append those categories and would actually eliminate the actual one, right? So in this case, when I'm running this, categorical features 2 stands for what column I want to encode. So here 2 stands for the column at the second index. So 0th index, first index, second index. So we have here, it would be encoding the column at the second index, right? And dot values is converting it into numpy array, right? It would convert it into numpy array. So if I would run this, right, it has converted into numpy array. Now let's verify it. How many values did we have in the status? We had 2 unique categorical values, that is developing and developed, right? And earlier we had 22 columns. So now what it would do is, it would eliminate the status column and it would add 2 other columns. So when we eliminate one column from 22, it gives us 21, and then it adds 2 more columns. So 21 plus 2 gives us 23 columns. So if we would fit it up, and if we would try to find the shape of it, we would come to know that there are 23 columns now. Had you had gone for, let's say, the 0th column, which is for country, you would have done it. It would have given us how many different countries did we have? We had some 193, if I'm not wrong. So 193 plus, 193 countries we had, right? So 193 countries it would do for, let's do it and let's check. So it would be 21 plus 193, right? We would run this cell again. Here we have done it for the 0th column. We would eliminate one column. So 22 minus 121, and then 193. So it should give us 214 columns over here. Yes, it is giving us 214 columns. So that is exactly how it works, right? So now let's see how many different unique values are we having. So it shows us that these are the unique values that we are having, right? And that's how it works. And in this section of the video, you have understood how do we pre-process the data, how do we encode the data, what are the different methods of encoding, like you can encode by label encoder, you can encode by ordinal encoder, you can encode one hot encoding, in what aspect do you have to use, what kind of an encoding. Before that, we also, in the case of imputing values in missing values, you had a look at how do we impute missing values. You can impute values all in one go, or you can impute missing values for a specific column using and 3 of the most prominent ways of imputing values, like you can impute value by mean, median, or mode. So that's all for this section of the chapter. In the upcoming section of this chapter, we'll be emphasizing on filtering data. How do you filter data, and what are the benefits of it? Till then, stay tuned.